So last meeting, we answered up to this number 3, for indeterminate members. So today is just a continuation of that. Let's move on to number 4. Number 4, a three-hinged arc is composed of 2 trusses hinged together at B in the figure. Compute the components of the reaction at A and find the forces acting in bars AB and AC. So we're looking for reaction at A and then forces acting in AB and AC. So it's pretty straightforward. Number 4. Reaction at A. As you can see, at A, we have a hinge. Whenever we have a hinge, again, the reactions are perpendicular and parallel. So perpendicular to the surface, let's call this AV since it's vertical. And then parallel. We're just guessing directions here, okay? So I'm just guessing upwards and to the right. And then let's call this AH since it's horizontal. Now remember, whenever we're looking for reactions at a support, this is a support, typically you're just gonna do moment on the other support which is at G. So let's do that. Right, summation of moment at G equals 0. Let's begin. AH passes through G, so ignoring that. Next, AV, rotate. That's clockwise, so positive AV. Perpendicular distance, 6, 12, 18, 24 meters. Next is 36 kilonewton force. Rotate, that's counterclockwise, so negative 36. Perpendicular distance is this length, so that's 18. Next, 60. Rotate, again, that's counter. Negative 60, perpendicular distance is 6 meters, right? And then we're not going to consider the forces passing through G since they create 0 moment. So there's no other force equate to 0. From this, please solve what's AV. Correct. Positive 42. Correct. John and Collins. Show up. Now we're not done. We're not looking for components. Oh, actually we are. Compute the components of the reaction. Right? So now we have 1. 42, positive, therefore correct assumption of direction, it's upward. So unit, kilonewton, upward. Now how about AH? Okay. So I'd like to ask, is AH 0? Please answer in the chat yes or no. Everybody, is AH equal to 0? Okay. And okay. Are those your final answers? So let's look back at our previous right? For this number, we wrote AH equals 0. Now why? Because there's no other horizontal force. Even here at this reaction on a roller, there's no horizontal reaction. Now what about here? This is a hinge. Now look here. This is also a hinge, meaning there's a perpendicular and parallel reaction as well. Right? This is GVGH. Now because there's a horizontal reaction here, that means we cannot assume that AH is 0. So basically, if you have 2 hinges as your support, you cannot assume AH is 0. So the correct answer is no. So very good for those who answered no. AH is not 0. Now, if it's not 0, how do we solve for it, right? Because if I take moment about G, which is the only other point that we can take moment on, correct? AH is not, AH is passing through it. Again, not included in the equation. So we can do, right? Let's say that in the problem that it's hinged at D, right? Hinged at D. And remember, for method of members, we can isolate members that are connected by a hinge. Now that includes trusses as well. We're not only limited to a single member. As long as the connection is just one, we can isolate that part. Meaning, I can isolate this entire section of your figure, okay? Because it's connected by a hinge at this point. So let's do that. Okay. Let's isolate. Okay. This is A, B, C, D. Don't forget to include your external forces. So this is 36 kilonewton. You have a support here with these reactions, AV, AH. Now from this, we can solve for AH. How? Remember again in method of members, we were doing moment about the hinge connections. So there's a hinge connection, we can do moment about D. Okay, so summation of moment at D equals 0. Okay, let's begin. AH, rotate about D. That's counterclockwise, so negative AH. Let's check the perpendicular distance, right? From D, it's this height. So look at the original drawing. What is that height? That's 9 meters. So 9. Okay, let's include those figures. Okay, so this is 9, 6. 6, 6. Okay, 9. Next, AV, rotate. That's clockwise, so positive AV. Perpendicular distance is this, which is equal to 6 plus 6, so 12. What else? We also have this external force, rotate, again, counterclockwise. So negative 36, perpendicular distance is this, that's equal to 6. Okay, so 36 times 6. There's no other force, so equate that to 0. Now please solve what's AH. Okay, correct. Okay. Got it first. Correct, Rain and Michelle. Chero, Leon. So 32. Bakit iba-iba kayong positive 32? Okay? Then, since positive, correct assumption, it's to the right. Okay? Now we have the components. The next thing we need to find is forces acting in AB and AC. Let's mark that out. AB and AC. Now, can anybody tell me what should I do next to solve for AB and AC? If you were to solve this on your own, what's the next step? I need to solve for forces in member AB and AC. Very good, Francisco and Colin. So Legado and Colin. Let's. It's method of joints or free body diagram at joint A. Okay. So method of joints, specifically at joint A. So that's here. So this is that joint. These are your reactions. Okay. Let's choose a different color. This is AV. This is AH. And then you have your AB and AC. AB for force in member AB, and then FAC. Now you're gonna deduce if it's compression or tension. Again, you can make an intelligent guess. So I have an upward force here. This should be in equilibrium, so I need a downward force, and I'll get that from force AB. So this needs to be downward. Okay. Next, FAC. Can either guess to the left or to the right. But if you've noticed in our previous examples, whenever we have a joint that looks like this force is usually in tension. So meaning this to the right, based on experience. Okay? But again, you can choose whatever direction to still be able to get the correct answer. Right, now we have this. Next step is to do your equilibrium equations. Summation of forces equals 0. Let's start with summation of forces vertical so that we don't have FAC. Okay, FAB, I need the vertical component. So to get that, I need your dimensions. There's no angle given. So most likely I'm going to get its slope, right? AB, first AB has the same slope as member AB and member ABD. Okay? Now, if you've noticed, again, wait, if I do this, we have a right triangle, okay? With base 12 and height 9. Okay? So therefore, if you want to take the slope, this is 12, this is 9, or simplifying, dividing everything by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. So we have a 3, 4, 5 slope again. Okay? So this has the same slope as this. So now that I have that slope, let's transfer that to our free body diagram. So again, 3, 4, 5 slope. So this is a 3, 4, 5 slope. Okay. We're using vertical component. So the vertical component of FAB is just multiplying it by the vertical side, which is 3 over hypotenuse 5. Correct? Okay. Then it's downward, so negative. What else? We have AV. Plus AV, and we already know the value of AV, it's 42. Way to 0, please solve what's FAB. Correct. Francisco and Kurt Legado de la Cruz. Mhm. 70. Positive 70. Unit kilonewton. Since positive, correct assumption, it's towards the point, so compression. Okay. Next, to get FAC, we're gonna do summation of forces horizontal or x and y equals 0. Okay. AH to the right, so positive. FAB to the left, so negative FAB. Horizontal component, so horizontal side, that's 4 over hypotenuse 5. FAC to the right plus FAC. Equate to 0, please solve what's FAC. Correct. 24. So correct, Kurt and GN. Gustos 3. Positive 24. So if AC is positive 24, therefore correct assumption, it's in tension. Okay, and that's it. That is number 4. Any questions for number 4? Please answer in the chat. Okay, good. And then last number, number 5. Okay. Beam carrying the load shown in the figure is composed of 3 segments. It is supported by 4 vertical reactions and joined by 2 frictionless hinges. Determine the values of the reactions. So basically, you have this beam with the following loads. We have reactions here, R1, R2, R3, R4. We want to know the values of that. And then our beams are also joined by your hinges. Again, whenever you have a hinge, you can separate the body connected to the hinge. Okay. So we're only looking for the value of reactions. Okay. So since we have reactions, it's safe to say there's supports at those points as well. Okay. So just remember that R1, R2, R3, R4 are most likely supports. So to solve, let's begin with this left side, since it looks simple enough. Again, connected by a hinge, so I can separate that. Okay. Now the reason why, since these are just reactions, and usually when we're solving for reactions, we take moment about the other supports. We can't do that yet because there's 4 supports. So if you take moment about any of them, you'll have 3 unknowns, right? The other 3 forces. So we can't do that. Again, we'll isolate one of the members. Isolating that, including your reaction and then external force. Okay, it's 40. And then don't forget, yeah. Then this is a hinge, right? Whenever we have a hinge, there's your forces, either vertical or horizontal. Now, since there's no horizontal force here, we can assume that there's no horizontal reaction at this hinge. So this is only vertical. Now let's give them a name. Let's call this a B. So this is RA. Okay. Now, if you look at this free body diagram, you'll notice that this is symmetrical, meaning the left-hand side equals the right-hand side. So that means the left-hand reaction R1 is equal to the right-hand reaction RA. And how do we solve for that? To get the reactions, you're just gonna get, wait lang, wala pa. We're gonna get the total force divided by 2. So 40 divided by 2, and that's 20 kilonewton. Okay? So let's just specify what we did here. Okay. By symmetry. So now we have our first answer. R1 is 20 kilonewton. Now, if you don't want to do that, okay, you don't want to do that, you want to make sure, you can just take moment about this joint. Moment about A, you'll get R1 is still equal to 20. Okay? But since it's symmetrical, this is the faster solution, so I'll do that. Next, this middle member, kind of complicated. So let's skip that. How about this? Looks simpler, so let's do that instead. Okay? So we have your uniformly distributed load, and it's 10 kilonewton per meter. Next, R4. This is one of the things we're looking for. And again, we have a hinge there. So there's going to be a reaction there. Let's call that your RB. There's no horizontal force, so the horizontal component of that reaction would be 0. And again, its span is 6 meters. Okay. Again, if you've noticed, it's also symmetrical. So we can use the solution by symmetry. Okay. So R1, RB, RB. RB equals R4, which is again, if it's symmetrical, it's forget the reactions at each end. It's just total force divided by 2. This is a uniformly distributed load. We're going to convert that to point load. To convert to point load, take the area. So that's height multiplied by base. It's a rectangle. So 10 kilonewton per meter times 6, which is your span or your base, then divide by 2. Okay, 10 times 6 over 2. What's the answer? Correct, Gian and Alyssa. Gustos tamay. Wait for me to ask. Because sometimes I don't need to ask how to solve, for example, what's 20 over 2. I can solve that. Okay. So just wait for me to ask before you answer. Okay? Para di sayang yung recitation. Correct, it's 30. 30 kilonewton. So again, that's one of our answers. If you don't want to do symmetry, you can take moment about point B to solve for R4. Okay? So if you want to practice, you can do that. Now, lastly, we have no other choice. You now have to isolate the middle member. Okay. Isolating. Okay. We have a distributed load here, right? And this is 20 kilonewton per meter. And then you have your reactions, the remaining reactions, R2 and R3. Then don't forget, at your hinges, which are at the ends, you also have reactions. So that's your RA. Then here is your RB. Then don't forget, this is 4, then 4. Okay, I think that's it, right? So for the unknowns, the only unknowns are R2 and R3, and once again, they're supports. Meaning I can take moment about those points. Okay, so you can just choose moment about 2 or 3. Let's try 3. Because if you notice, if we do summation of moment about 2, we have uniformly distributed load on the left side, and then uniformly distributed load on the right. So it could be a bit complicated. Okay, so instead, I'll just do it here. So summation of moment at 3 equals 0. Just start, RA, rotate, that's clockwise, therefore positive. RA, perpendicular distance. 14. So by the way, forgot. Remember the rule that if you're doing or you're moving on to a connecting member, the reactions at the hinge should be the opposite. So I forgot to do that. So don't forget like I did. So for example here, right, this is the first free body diagram that we did. We assumed it's upward, okay? So on the connecting member, member AB, our A now should be downward, okay? So let's do that, downward. Same thing here, right? We isolated this part. We assumed it's upward, right? Therefore, on the connecting member, it should now be downward. Okay, so now rotate. That's counterclockwise, so negative RE times 40. Next, R2, clockwise, so positive R2, perpendicular distance 10. Next, here, RB, clockwise, so positive RB, distance is just 4. Then don't forget, we have this uniformly distributed load, and we can convert that to a point load again, right? And that point load is just equal to its area, so that's just 20 times 10. And then its position is going to be on the center or at the midpoint, center of your area. This is just a rectangle, so it's located at the midspan. Total span of your uniform load is 14, therefore half of that is 7. Therefore, this is 7 meters. Okay? So now, rotate. That's counterclockwise, so negative. Point load, 20 times 10. Sorry, it's not 10. Again, total span is 14. 10 plus 4. It's 14, not 10. 20 times 14, then perpendicular distance to 0.3 at 7 meters. There's no other force, equate to 0, we solve. What's R2? Correct. Correct, John. And Geyser. So, Chua de la Cruz. Chua. 212 unit kilonewton. Yeah. And then the only thing we need to solve for is R3. And to do that, we can just use one of the other equilibrium equations, which is summation of forces vertical equals 0. So negative R8 plus R2. This is downward. Again, you're using the point load. So minus 20 times 14. Plus R3 minus RB. And from this, please solve R3. Correct. It's 118. Very good. Lloyd and Kenneth Sosa de la Cruz. 118. And those are your answers. So that's number 5. And Kenneth, kanino ba nilagyan kong score? Oh yeah. Yeah, I did. But tama naman Kenneth de la Cruz. Okay. All right, again, That's number 5. Any questions for number 5? Please answer in the chat. Okay. Since you don't have any more questions, that ends our topic for indeterminate members.